So this is the example that we're going to use to find the initial velocity of a particle undergoing SHM. A small object obeys SHM with a time period of t equals 10. It's halfway between the equilibrium position and one of the extremity points located 40 centimeters away from the equilibrium position. Find the initial velocity of the particle. So it is a lot of information. It's going to be flipping back and forth. But if you want to give this problem a try, go ahead and then come back for the solution. So as always, blank screen. So the time period, capital T, is 10 seconds. We're told that it begins halfway between the equilibrium position, one of the extremity points, and the extremity point is 40 centimeters away from the equilibrium, so that means the amplitude is 0.4. We're also told that x at the initial position is 0.2 away from equilibrium. So if we start with x is a sine of omega t plus epsilon, we're going to have to find epsilon, and it's not immediately obvious what it is given the information, so we're just going to have to simply solve for it. And I'll just get my calculator ready, as one should have done, or I should have done ages ago, but I didn't. And again, they should calculate is in radians, just because we do simple harmonic motion in radians. So filling all this in, we get 0.2 is 0.4 sine of. Now omega we're just going to discount for a minute because timesing by the initial t, so t is 0, that's just going to be sine epsilon. So that means if we divide it by the 0.4, we get sine epsilon is a half, which implies that epsilon is 5 pi over 6. It's just pi over 6. 5 pi over 6 is the other solution, but we tend to just take the first solution available to us. So we just have epsilon as pi over 6. We can work out omega as well, given omega is 2 pi divided by 10, which is just pi over 5. So the displacement is 0.4 times pi over 5t plus pi over 6. Now, a key thing to remember is that velocity is the rate of change of distance over time. So if we differentiate this, we get the pi over 5t coming out the front and differentiating, so it becomes pi over 5. So it becomes 0.4 times pi over 5. Oh, there should actually be a sine in here, that's the problem. And then the sine becomes a cosine, and the inside remains the same. So differentiate this out gets the pi over 5, differentiate that gets the cosine. Now 0.4 is 4 over 10, so it'll be 4 pi over 4 pi over 50. Let me just double check this. Yeah, 4 pi over 50, or 2 pi over 25 cosine of pi over 5t plus pi over 6. Now we're looking for the initial velocity, so we're going t is 0. And so the velocity is just 2 pi over 25 times cos of, well, pi over 5 is going to be 0, so it's going to be cos of just pi over 6. And cos pi over 6 is square root of 3 over 2. So I'm going to have to try things. So it's going to be 2 pi over 25 times square root of 3 over 2. And so it's going to be 2 root 3 pi over 50. Actually, the 2 and that cancels. And so we just get root 3 pi over 25. Which is about 0.22 meters per second. And that is the initial velocity of this particle.